Okay, now during this webinar, we're going to try and keep it as interactive as possible. So if you have any questions, please use the GoToWebinar question panel to type in those questions, and I will try to, I might either stop during the webinar to answer those questions, or I will stay at the end to answer them as well. So if you have any questions, please do type those questions in there, and I'll do my very best to answer them. Okay, so today's agenda is really to, first of all, take a look at the similarities and differences between SolidWorks and Onshape, and really how similar they are, what the differences are, and how easy it would be to move from one to the other. Then we'll take a look at moving legacy data. Now, typically, people who have lots of project data in SolidWorks want to move some or all of that over into Onshape. So we'll look at the reasons to do that, the best practices, and I'll also do a live demo of transferring that data from one to the other. Then we'll take a look at creating a consistent UI experience. So again, if you're moving from one to the other, or you're using them both at the same time, it can be quite confusing if the user interface is too different between the two. And then we'll just do a quick overview of understanding the fundamental differences from going from SolidWorks to Onshape. So we'll see how Part Studios work, how assembly mates are different, and how we share data. Okay, so from a similarity standpoint, both systems, both SolidWorks and Onshape, they're professional CAD systems. They're used by thousands of companies, and both systems primarily create parts, assemblies, and drawings, which really is the bread and butter of every engineering company. They are both parametric, feature-based, and associative 3D modelers. That basically means, of course, that you can define a model with parameters or dimensions. It's feature-based, meaning that you're not dealing with geometry. You're dealing with things like holes and fillets and chamfers. And associative, essentially meaning that if you make a change in a part, it will update in the assembly, or likewise, you change assembly, it will update in a drawing, and every change propagates throughout the entire project. Now, between the two, there is a familiar design workflow. The essence of how people interact with 3D parametric modelers has not changed really over the last 30 plus years. So there is a familiar design workflow there. So it's not a complete, it's not completely alien when you move into Onshape. Both these systems are based on Parasolid and D-Cube technology from Siemens PLM. And these are really components which form the backbone of many, many CAD systems. So what you'll find as well is because they are based on the same technology, the quality of geometry transferring from SolidWorks into Onshape and vice versa is perfect, basically, because there is no actual physical geometry recalculation. It's basically just using the same geometry engine. And the other big similarity between SolidWorks and Onshape is that they're both founded by the same team. So the original team that founded SolidWorks some 25 years ago also founded Onshape just a handful of years ago. So from that, they recognized the opportunity to generate or create a new CAD system based in the cloud and all the benefits that go with that. And they then built the Onshape team and the Onshape company and product. Now, just a quick overview of those similarities as well. Now, I mentioned that both do parts, assemblies, and drawings. They can do sketching, 3D modeling, both do surfacing, very similar capabilities there. Sheet metal and direct editing, yes, we can do that. So direct editing is where you will take a solid body from an import and make some edits to that, and I'll show that a little bit later. And configurations as well. Now, those three items, sheet metal, direct editing, and configurations, are something that, yes, both systems has done, but Onshape has had the opportunity to step back and take a look at how those things were created originally in SolidWorks and come up with better ways to do it. So if you've never taken a look at those items within Onshape and you are familiar with them in SolidWorks, then please take a look. There is some webinars previously on what we call Parametric Modeling 2.0, which shows basically a lot of the differences of how we've implemented these capabilities. There are, however, some things that SolidWorks can do that Onshape cannot do yet. SolidWorks has been around 20 plus years longer than Onshape, so it's not really a big surprise. Things like weldments, which is creating welded steel frames. Now, I've put an asterisk there in the Onshape column because we can do that with our custom feature scripting language called FeatureScript. So there is a custom feature called Beams, which does probably 90% of the capabilities of SolidWorks weldments. So while we don't have it officially in the product, many people are using that script to reproduce weldments capability in Onshape. And then there's things like model-based definition, which is a cost add-on to SolidWorks, again, which Onshape doesn't do just yet. As far as assemblies are concerned, we have mates, limits, relations, that's gears and so on, flexible sub-assemblies. We do them differently, which I'll show in Onshape just a little bit later. And then things like standard content, things like fasteners and so on, is included in Onshape. It is a cost extra in SolidWorks. Basically, you have to have SolidWorks Professional or Premium to get Toolbox. In context editing, it is something which is a standard in SolidWorks, so perhaps you should get half a check mark in there. But the way Onshape is implemented, it makes it bulletproof. There is the danger of making references between multiple parts in an assembly or creating in-place mates and things going horribly wrong when there's a design change. On the other hand, they have much better interference detection in assemblies. We do have it, but it's not as good as theirs. So there is a lot of similarities and just slight differences as well. And then built-in release management comes as standard with Onshape Professional. With SolidWorks, of course, you would have to have PDM standard or professional, which comes in SolidWorks Professional or Premium or an additional add-on. So it is cost extra. And then finally, just to wrap up on this quick overview, is drawings. There is a lot of, again, similarities there. They do have more capabilities. It's been around longer, like I mentioned, but the bread and butter things that you need to create drawings, so views, tolerancing, GTOLs, animation, annotations, weld symbols, whole call-outs, all that kind of thing, and bill of materials is available in both products. They have automatic balloons. We have manual balloons. They have automatic exploded views. We don't. Integrated DWG viewer is part of Onshape, but for SolidWorks, you'd either have to use DraftSight or eDrawings. Okay, so it's not integrated. It's an extra software you have to install, but they do have that capability there. Okay, and really then just really what the differences are, or really why companies choose Onshape. If we looked at the previous checkboxes, there isn't really a lot of differences. And of course, SolidWorks does have more capabilities because it's been around longer. But some of the main benefits of Onshape is really that it's all based in the cloud. So this is why people are moving to Onshape from SolidWorks and other CAD systems as well. In regards to having no downloads, installs, or service packs, there's no version conflicts or file incompatibilities. There's no Onshape 2018, Onshape 2019, for example. We release every 3 weeks and everybody's always on the same version. So there's nothing to, every 3 weeks, you don't have to download or install anything. Nobody has pop-up dialog boxes saying, this file is incompatible, please upgrade to the latest version. Because there is no files and everything is in a database, there's no files to lose or corrupt. There's no crashes or data loss. Now, again, I've done a whole webinar on how Onshape deals with crashes and how we can actually claim there are no crashes, but indeed there are not. You don't have to manage license keys because everything's just done by login. There's no PDM required, it's built in. There's no emailing files or IP security issues because sharing data is all done within Onshape without the data ever leaving Onshape. You can share data with people either in your own company or to third-party suppliers very securely. And again, we'll take a look at that a little bit later. Okay, so let's talk about legacy data. Now, SolidWorks is over 22 years old. Okay, I said 25, but 22, okay. And really thousands, hundreds of thousands really probably use SolidWorks. It's been around for a very long time. It is probably the most popular CAD system out there. However, it hasn't really progressed with regards to capabilities, at least for the last 10 years, maybe more. So there's a lot of companies who are probably wondering why they are still paying their subscription dollars and not really getting much benefit. And then taking a look at Onshape with regards to all those things I mentioned just previously, there is not only does it cost less, there is a lot more benefit to be had. Now, each of those thousands of companies, of course, probably has hundreds and tens of thousands of files. So that is a lot of data. And each file, of course, could have, a massive casting in it or, a multi-sheet drawing. There is a lot of data to be had there. So what do you do with it? If you're thinking of jumping from SolidWorks to Onshape without actually, switching one off and going to the other, then there's a few things that you should consider. So first of all, the recommendations really is to start all your new projects in Onshape. So if you were to switch one off tomorrow and start with Onshape, then just start all your new projects in Onshape. So if there's any existing projects going on in SolidWorks, keep those going in SolidWorks until those projects go to completion. So start all your new projects in Onshape, but keep all your archived data in SolidWorks. Now, by archived, I mean data that you, of course, need to keep. Data you might need to keep for, for products that are out in the field, or just for legacy reasons, you might want to reuse some old data. But if it's not in active use, then the best thing to do is keep it archived in SolidWorks. You've already paid for the software, you own it, so just keep a Windows PC in the corner with access to all that archived data. It's very tempting to do like a bulk upload of data into Onshape, but really it doesn't really serve a purpose. Of course, Onshape will convert it for you because it gives you unlimited storage, but really you have to think about where the value is in doing that. And I'll talk about some of the limitations that appear in trying to transfer data in just a moment. So again, the recommendation is to only transfer what you need when you need it. Okay, and those might be standard parts, so something that you use regularly within your business, or bought-in items from suppliers, and then you have to think about, okay, well, if it's let's say it's a valve or a cylinder that you use very often, is it a configured model? Is it something that you do lots of modifications to? If it is, then you might even consider remodeling it. Okay, so if it's something that you use regularly, remodeling it in Onshape might give you a little bit of pain up front, but the long-term benefits will certainly outweigh that. Okay, so what are the limitations when dealing with legacy data? So Onshape imports SolidWorks parts and assemblies only. Okay, so please bear that in mind. So drawings is something which is it's a very difficult thing to do technically, and that is why we've not implemented that as yet. Not saying we never will, but parts and assemblies is really, from a data reuse standpoint, this is what people want to use. So it's a standard part, you're going to reuse it. It's a bought-in item, you're going to reuse it in a new Onshape project, rather than trying to manage and work with legacy drawings. Next thing is that SolidWorks imports SolidWorks files from 1999 onwards. So unless you are a user of very old SolidWorks, you've not updated it since before then you're out of luck. But if you've got any old files which you need to use in Onshape, then all you need to do is just open them in a newer version of SolidWorks and save them again, and Onshape will be able to read those. So with regards to parts, no features are imported, only bodies. Now, bodies, I mean solid bodies of representing a part, or a surface body, or a wire body, which is a curve or a helix or something like that. So this is very typical between any CAD system. So the way CAD systems implement their core technology, they might all use Parasolid for their modeling kernel and D-Cubed for their sketch solver, but all the feature code on top is proprietary to that that CAD vendor. So there's no way we can reverse engineer it, and there's no way they're going to let us know how they've done it either. So all we can do there is just take the solid bodies as the prior solid body and use that, which, again, if it's a bought-in item or a standard part that doesn't need modifying, that isn't really an issue. From the assembly standpoint, no mates are imported, only relative positions. And again, we'll look at that in a little bit more detail in a little while. And no configurations are imported. So again, if you have a hydraulic cylinder that you need to recreate in Onshape, there is ways you can do it. For example, you can take the Excel spreadsheet generated in SolidWorks and export that remodel it in Onshape, and then export that Excel data into Onshape to recreate the configured part. So it's not impossible, but of course you have to think really what are the main benefits of doing it. If you're going to get lots of benefit out of it, then it's certainly worth doing. And just to reiterate, drawings are not supported. Okay, now, as mentioned, these limitations are the same when transferring data between any CAD system. So it's not something which is peculiar to Onshape. So if you were going to move from SolidWorks to, I don't know, CATIA, which is crazy because it's from the same company, they use completely different kernels, completely different data structures, so there's no compatibility. I've placed an asterisk next to that because there are some slight exceptions to that rule. So, for example, SolidWorks can read the mates in a Creo assembly, for example. So there are some exceptions to the rule, but there's no blanket conversion from one document. From one CAD system to another. Okay, there's a question coming in. Is there a feature in Onshape like FeatureWorks in SolidWorks to get the features? The answer to that, the short answer to that is no. Okay, but what I would also question, and we'll look at in a short while, is the validity of the FeatureWorks capability, because essentially what that is doing is looking at the geometry and trying to reverse engineer it into features, which from experience really only happens on the most simplest of prismatic parts, and then only less than 50% of the time. So you have to do a lot of manual editing to get it what you want it to do. So what we'll look at in a short while is how we can do direct editing, which is a little bit more controlled and a little bit more sort of thing you want to do if you're just making some slight modifications to a model. And again, what FeatureWorks does, it doesn't maintain any of the design intent. So, for example, if you specify this hole should be so far from this edge, it doesn't have any of that data. It'll just create the hole size, and then you'd have to manually go and add that in later. So again, there's a lot of rework in order to get a usable model. Excuse me. Okay, so let's take a look at how the best way to transfer data from SolidWorks into Onshape. Now, I mentioned that Onshape will import parts and assemblies, but since SolidWorks creates a single file for every single part and a single file for every single assembly, that's a lot of files. If you were to import a SolidWorks file into Onshape, SolidWorks assembly file into Onshape, then it wouldn't know what to do with it because it doesn't know where the parts are. So the only way to keep those references between assemblies and parts and keep that assembly structure is to use the SolidWorks Pack and Go feature. Now that is available under the File menu in SolidWorks. So if you're thinking of moving an entire project over, then use the Pack and Go feature. If it's just a single part, then just open the part in Onshape and that will work fine. But even if it's the tiniest subassembly, Pack and Go is the way to go, because that will keep those references between the parts and the assemblies. Now, there's some things which are not checked by default, which you should probably make sure they are checked. First one at the top there is include toolbox components. If you've got any fasteners in your assembly, which I think there is, so there's some socket head cap screws in this example, and there's a spur gear. So there are some toolbox components there. The next thing to do is to save as a zip file. So in order to get the data into Onshape, you need it as a zip file. So if you input the zip file, Onshape will recognize it as a SolidWorks assembly, and it will also recognize that all the parts are in the same zip file, so it knows how to find them, and it knows how to do the references between them. The only thing that you should remember, and it does it by default if you use Pack and Go, is that the zip file, the name of the zip file, should be identical to the name of the top level assembly, so that Onshape knows which is the top level assembly. Because again, if there's 10 assemblies in the zip file, there's no way to know which is which. And then I think is the default, flatten to single folder. If you've got them all in different folders, Onshape will read those. It can find those relative paths inside the zip file, but just to make sure, if you enable the flatten single folder, is definitely the right thing to do. Okay. All right. So let's take a look at creating or importing files in Onshape. Okay. So if you have so here is a folder with a bunch of SolidWorks parts and assemblies in there. If you created a Pack and Go, then there would have been a zip file with the same name of the top level assembly, which is hydraulic pump. However, if you don't have access to SolidWorks, but you do have the actual files, you can create your own zip file. Notice here that there are toolbox parts in here, because this was originally created from a Pack and Go, so it automatically picked up the toolbox parts. So do bear that in mind. Okay. In fact, just bear a second, because I just realized that is the wrong data. So let me just restore that, put that back. Okay, and I'll extract that. Okay. All right, sorry for that little interlude there. So we have, so this is better. Okay, I realized it was the wrong assembly I had there. So if you don't have the zip file, then you can create your own. Now, questions just come in there. Is it able to import or recognize metadata within a part or assembly? The answer to that is no, it doesn't. It will recognize the relationships between the parts and assemblies, but if there's any metadata like like vendor, supplier, material, that kind of thing, then no, it's unable to extract that information. Okay, so let's create a zip file from this. Now, whether you're working on Mac like I'm here or on Windows, you can just use the compress function, and that's going to create for me an archive. So all we need to do here is just make sure it's got the same name as the top level assembly. So let's just copy that from there. Control C and Control V. So there's the pump. Okay, so there's the zip file. So again, you can do it manually. You don't actually need Pack and Go. Okay, and then just go ahead and import that into Onshape. So there's a zip file. Now, there's certain things that you should remember when working with SolidWorks data. Now, we'll talk about this first option in a moment, but the most important one, well, it's handy anyway, is that SolidWorks and Autodesk Inventor are the only two CAD systems which have the Z-axis pointing out of the screen rather than up. So if you were to leave that unchecked, then Onshape, when it's imported, it'd be rotated by 90 degrees. You can edit it after the fact, but if you know the data is coming from SolidWorks or Inventor, check that option there, and then it will appear on the screen as you would expect it to. The second option here is allow import of parts with faults. Doesn't really apply to SolidWorks. I mentioned earlier that we're using the same modeling kernel. The quality of the data is very good, so you don't really need that. However, it doesn't hurt to have it checked. You might find data that's in IGES format, which is very old, please don't use it, or it comes from Creo, Pro Engineer, or some other obscure CAD systems, you might find that there are gaps in the surfaces. So if you leave that unchecked, Onshape will just ignore it. It'll say this part has got a fault. I'm not going to import it. If you do check that, it might import it as a bunch of surfaces rather than a solid. But like I say, it doesn't actually harm anything by having that checked. If you don't check it and then import it, and it comes up with a blank document, you might wonder what's going on. So at least it will import something if you check that box there. The last option here is about the assembly structure. You can either create everything in a single document, and it will create an element tab in Onshape for every assembly and subassembly, and a single one for all the parts. You can split them up into multiple documents, which is useful if you've got multiple people in the project working on different areas of it. You could do that. Or the third option is to flatten assemblies into part studios. Okay, I'll do this one first, and then I'll do a second one, the other option, to show the difference between the two. Now, this one will ignore the assembly structure and create one part studio with all the parts in it. Now, this is ideal, really, for what I'm importing here, and you use this for small sub-assemblies, assemblies which have been imported from suppliers. For example, in this case, this hydraulic pump has been sent by a supplier. I'm not really interested in the assembly structure, and you can see that it's uploaded it, it's translated it successfully, and I can now go ahead and open this document. Now, there are two tabs that you'll always find in the document. The first one is the actual file itself. You can say it's translatable, it's given a file name. The reason why we keep that is that so you can version control it. So if I was to go ahead and create a version in this document, you would always be able to get back to that. Even if you deleted the tab, you could always get back to it. But if you don't need it, you can go ahead and delete it if you wish. Okay, I'll leave it there for now. So if we look over in this single tab here, this is a part studio. And if you're unfamiliar with part studios, we'll take a look at that in a short while. But the idea is that everything has been put together as one import made up of multiple individual parts. Okay, so you can see those multiple parts there. If you're not interested in assembly structure or motion, then you can just leave it like this and then reuse that in another document. One thing to note as well, that if you are looking to use this in other documents, so if this is a standard part, you want to create a standard library of components and you reuse them over and over, is to create a version. Now, creating a version enables a part to be linked into other documents. So if you don't create the version, when you go to link this document, it'll say there are no versions in the document. So it's something you just need to do in order for Onshape to be able to see those documents inserted into other documents. Now, the reason why we do this by versions rather than just do the latest is because it gives you more control over what versions you're using in assemblies. So you could have this version, you could have a version with a longer shaft. You don't want the shaft changing length every time you open a document. You want to be able to say, oh, I'm using this version, I'm not interested in the other version, for example. Okay, so that is the one way of doing it, by doing it all in one parts. But if you are interested in assembly structure and motion, you can import that, and I'll do it from here rather than go back to the documents page. And this time I'll import all the assemblies and parts into a single document, and I won't bother with that. Okay, so you can see there are a number of tabs been added here now. So there's the top level assembly. So we can see all these parts here. There is also sub-assemblies in here. Okay, so it has kept the assembly structure. So for example, there's a sub-assembly here, there's a sub-assembly here, another one here. But this will sometimes confuse people when they look at it. So this is the part studio, which is containing all the parts. Now, all of them have actually been added to the origin in this part studio. Okay, so you can see they're actually not in their relative positions. So that's the difference between importing it as just as a flattened part studio as opposed to having an assembly structure in there. However, if you do make changes to these, of course they will update in the assembly. Okay, now let's just take a look at some assembly things for the moment. Now what you'll see is we've got the parts together in the assembly, they're in the correct location, we've got the assembly structure, everything looks good. However, if you do this, you can see that nothing is mated together. So the relative positions have been added, okay, but they're not, but there's no relationship between them. Okay, so a couple of things you could do here. If you are not interested in the motion, let me just undo a few of these actions. So for example, you don't need to see this shaft rotate, then what you should do is use the group command, which is positioned here, and just box select everything. Okay, group command, what that will do is make everything appear as one item. Okay, so you can drag that around. So that means that if you then to use this standard part in another assembly, it's not going to fall apart when if you didn't do the group and you inserted this into another assembly, the parts would be able to move separately from each other, which of course is what you don't want. Now, if you did want to have the motion in there, let me just undo that group there. Then what you might want to do is take. We'll just take. Sorry, the group's still there. Let me just go ahead and delete it. So we'll just take this shaft and we'll just move out here. I'm not, for the interest of time, I'm not going to bother with the gears which are inside this assembly here. Okay, so we'll take that out of the equation and we'll group all those together as such. So these things will move. Oh, it's still in the group. Hang on. Let's take it out of the group. Okay, there we go. So these are all grouped together. Apart from that. Okay, let's just get rid of that for now. So these things are all grouped together, and this is separate. So if you want this shaft to rotate, again, I'm not bothering with the gears just for the interest of time, is that we can then put in a relationship between them. So let me just hide that one. And I might then want to put in a mate, which is a revolute mate between the end of this shaft and the end of this bearing, for example. So that then gives us the rotary motion that we want. And probably what you need to do here is just take one of these items and just fix it, just so you can spin it round. One thing is worth mentioning that the fix command in Onshape is not the same as fix in SolidWorks. So the fix command in Onshape is really only for the situation where you saw there, where I was trying to rotate this thing around, and it started moving everything else. So if I then inserted this into a top level assembly, the fix command no longer is active in the top level assembly. So something worth remembering. And for a more detailed information on that, please take a look at the help file, and we've also done some blog posts on it, just a little bit more background. Okay, so it's possible to do those relationships in there in the assembly using the assembly mates. Now, the assembly mates, as you saw there, different from what you are familiar with in SolidWorks. Rather than create individual mate, align, insert, offset mates, they're done in one command. So in this case, it's a revolute or a fastened or a cylindrical or a planar mate. So there are a lot of single command mates which will do the same thing. Now, with regards to reusing or editing existing data, then let me just go ahead and hide some of these other items. Just to make it a bit clearer, let me just change the color of that thing. Okay. Now, if you needed to make some design changes to some existing geometry, now, of course, if you had SolidWorks, they have the equivalent of FeatureWorks, but really what FeatureWorks is doing, as mentioned, is trying to look at the geometry and make sense of it. And most of the time, it doesn't do a great job. So if you need to do some edits to this, there is a bunch of direct editing tools which are available on the top of the toolbar here. So there are 4, but out of those 4, there's some very powerful things you can do. For example, delete face. one of my personal favorites. So if you've got something like a feature, it could be as simple as a hole, or it could be an indented boss like this. You can delete faces and just get rid of that feature entirely. Now, you don't have to pick everything. You just really need to pick the geometry which makes up the face, because the fillets really are neither here nor there. So you'll see there from the preview that feature is gone entirely. And you can do the same on the other side just by selecting those pieces of geometry. So very easy to do to remove geometry. You might also want to change a fillet size. So the modify fillet, which is available in Onshape, something, SolidWorks can do some of this direct editing. Modifying fillet is one of the things it can't. What you'll see is when you select a fillet, it automatically tells you the size of that fillet, which is really handy. Sometimes I use it just to measure a fillet. Sometimes if there's no way to physically get a nice rounded edge to measure the radius using the measure tool, the modify fillet command will actually tell you the relative size of that. So you can actually just go in here and say, change that to 2, 3, 4, whatever, and you can see it's modifying that entire fillet chain. So it does understand that almost in a FeatureWorks-like way, what the changes are. You can change the size, or you can get rid of it completely, and it'll remove it from the entire model. Okay, but we'll leave that on there at 2 mil. We can also do things like move face. Now, move face, the idea is that you might take a piece of geometry and say, just picking that top face there, it will automatically pick those fillets and allow you to move them. So that will give you the option to make quick changes. You can move by offsetting, translating, or rotating. So again, if you needed to change the size of this thing, again, we're just going to pick all 4 faces and then modify those sizes, neither bigger or smaller. So you get seeing all this capability to be able to modify a design. And what you'll see as well is that each of these features exists in its own right within the model tree. So if you were to edit this move face feature, you see you can modify that, and the dimension that's added gives you that relative offset when making a change. And finally, the last thing I'll show on here is replace face. Now, replace face is useful to get rid of features, but also to change the shape of the topology of a model based on some other geometry. So, for example, if you want to replace these 3 faces here, and replace it with another face, it can be a face off the model, it can be a surface you created, it could be a plane. Then we see you can take that, and it's completely removed that. So it means that I've not had to go in there and create a sketch and extrude and reattach the fillet. Everything is created on there to modify that model. And again, very quickly we say, let's get rid of these 3 sides and make it level with this face here. And again, we've modified the geometry fairly significantly from what it was. So when I mentioned you can import your SolidWorks data, you need to do some slight tweaks with it. 9 times out of 10, the direct editing capabilities in Onshape will provide the capability to do that. If it's more other things, like you need to add holes or you need to add bosses, then of course you can just use any of the standard features to add or remove geometry from the model. Okay, got a couple of questions on the side. A couple of questions here. It says on the right side of your test bar, see Google Drive logo. Okay, that is that is in my that's in my MacBook title bar there. So that's no. There's no relationship with other cloud services. So everything is done through Amazon Web Services. But there are some pretty cool things you can do with Google. For example, you can insert Google Docs inside an Onshape document and access it through there. Plus, we have a bunch of other third-party partner application providers which do everything from simulation to CAM to engineering calculations to all sorts of things, and all those are accessed through our App Store. And again, all these different other cloud services. Another question, does Onshape have the equivalent of a SolidWorks Hole Wizard? Yes, we do. This is So when you use the whole feature, all it's looking for is a point to place it on, which could be the origin. Sorry, looking for a sketch point. So you can specify, whether it's a simple counterboard, whether it's a through hole, whether it's ISO or ANSI, tapped, what size do you want it, M16, and then it's going to automatically select all the correct data for you and apply that to that hole. And then when you create a drawing, there will be a hole call out and it will show the tapped feature in the drawing as well. Okay. And another question is saying the company is responsible for customer data and company data. Is it possible to synchronize data with your company servers in case you cannot pay subscription or any other reason? The answer to that is yes and no. So the Onshape does not use files. Onshape uses a database, so there is no way to there are no files, so you can't export it in any kind of format to be reused later. You can export data in neutral formats like STEP or for your 3D models or Parasolid, or for your drawings you can use DWG, DXF, PDF, but not the actual Onshape native data. What will happen is if your subscription expires from Onshape, then the data becomes view only. So you can still view it, you can still print it, you can still measure it, all that kind of stuff. But it becomes view only. When you renew the subscription again, it then becomes editable again. So you can also export it while it's in view only as well. So the data's there, but the actual feature data is proprietary in the database. So if the subscription expires, then no, there's no access to it. As a follow-on question for the hole wizard, is saying, are holes recognized when imported from SolidWorks? No, they're not, because again, it's just recognizing, they do their implementation of holes, we do ours, as every other CAD system does. So there is no compatibility between the two. Okay. Next thing I wanted to take a look at is if you're working through moving from SolidWorks to Onshape, something just as simple as user interface and mouse controls can make a big difference. For example, the default, I'm using the third mouse button here to rotate this model on the screen, and the wheel does zoom, same as SolidWorks, and pressing the middle mouse button does pan. Whereas it's control and middle mouse button on SolidWorks. So trying to use two different systems at the same time with different mouse controls, I don't know if you've ever tried it, but it's virtually impossible. So what you can do is, under your preferences in the top right-hand corner, is specify the mouse controls. Now you'll see by default, it's going to default to Onshape, obviously, but you can set that to SolidWorks or NX or Creo or AutoCAD. And that will then change the behavior of the mouse to be more consistent with what you're used to. So when you've got years of muscle memory, you don't have to lose all that going between the two systems. So now rotate is the middle mouse button. The pan is control the middle mouse button. Zoom is the scroll wheel. And you can reverse the scroll wheel zoom direction as well if you wish. Because again, SolidWorks does it the opposite to what every other CAD system does. So if you want to set that, so really turning that off and saving those, we'll set that to be the same as SolidWorks. The other thing is that, yes, there are some differences between the user interface, but there are also a lot of similarities. And one of them is the S key. If you've ever used the S key on SolidWorks, it's just a quick way to bring up a shortcut toolbar next to your cursor for your most frequent commands. So the same can be done in Onshape. So you can see for sketching, or for parts, assemblies, or drawings, you can create a different shortcut toolbar. So if we're in the sketch and we use, a conic a lot, you can add the conic to the toolbar, polygons and so on, or take things out. Likewise then for the parts, again, if you do a lot of delete face, you can add that. If you do a lot of the direct editing, you can add all those to the S key toolbar. And that just means that whenever you are within a document, that you can press the S key, And I didn't save those settings, so that's why they're not appearing here. But you can see I can press the S key, and I can then get quick access to all those commands directly from the right next to the cursor. If you have a multi-button mouse, then it's even better. So if you can assign the S key from the keyboard onto one of the buttons on the mouse, then it's going to make it even more efficient to get quick access to those commands. All right, the final thing we'll take a look at, again, is really just the main differences in using Onshape. You can tell a SolidWorks user who's using Onshape for the first time and perhaps not gone through the training. The best thing to do is to go through this Learning Center here. So if you click on this Learning Center button, it will take you to the Onshape Learning Center, which has a bunch of videos for self-paced training. So depending on what level of subscription you have different access to different courses. So for example, there's an Onshape Fundamentals to CAD, an Onshape Fundamentals to Data Management. This is free for everybody. There are also instructor-led courses, which are a cost option, but these are done over the web, and we run these every week. So if you really want an intense bootcamp type training, it might be worth investing in one of these training courses. There is also a number of other self-paced courses. Some of those are only available to people who subscribe to Onshape Standard or Professional. So for example, here's one on direct editing. Having said that, all the webinars that we do are recorded. So if you go to the main Onshape website, and then look under the Learn area, you'll see of course there's webinars that you can go to. There's also the video library. So under the video library, we have topics on everything. In fact, there's the webinar from last week. So there's topics on everything. So there's webinars, there is tech tips. Okay, and if you look on the blog, and really if you just do a Google search for Onshape things, you'll be able to find what you're looking for without really having to go through the whole training and video course. I'd highly recommend it, of course, but if you need to know something really quick, then simple Google will give you the correct answer. If you're stuck on anything, even if you've only been using Onshape for an hour and you're stuck, use the forum. Again, you can use this from the help menu here and go straight to the forum. Everybody on there is really helpful. It's manned by Onshape employees, but the more people who answer are from the Onshape community. And quite often you'll get 4 or 5 people falling over themselves to answer your question for you. So it could be something really simple, something really complex. All that we ask is that you describe the situation clearly, preferably with images, but also include this URL here at the top. So that URL at the top there, please copy and paste it into your forum post and make sure that the document is public. Now, to make sure a document is public, if you're on the free plan, it's going to be public anyway. But if you're on a paid plan, then you would have to then go to this public, go to share and then public and then make public. Okay. Now, if it's sensitive data that you don't want to share, then just try and make an example of that represents what you're trying to do in a separate document and share that instead. It just means that people on the forum can understand the problem better and have an example to work from so that they can then edit your example and send that back to you so you can see how to get around a particular problem that you're facing. While we're here looking at shared data, I mentioned that the differences between creating parts, assemblies, and sharing data, the data, because it is all in a database, never actually leaves our servers. So if you want to include somebody on there, you could put in their email address and then specify whether they can edit or view a document. Okay. So if you only wanted to have somebody view a document so they can perhaps quote on it, then you can just give them view and comment access. So they will then receive an email, which then gives them a link to open Onshape and will display your document or drawing or whatever it is within a web browser. They don't have to have their own account. Onshape will take care of that. If they do have their account, that is fine too, but they don't necessarily need an Onshape account. If at any later date you want to give them edit permissions, then you can specify it as edit. You can then specify whether they can copy it, whether they can export it, whether they can share it onto other people. Probably don't want to do that. But if it's a supplier who's going to machine the parts using their own CAM system, then you want to give them export capabilities and then update that. Okay, and again, I just want to reiterate that those capabilities for somebody else to edit your document requires them to have an Onshape standard or professional license. So the Onshape free account does not permit editing of private documents. You can edit public documents, but not private ones. Okay. Last thing I'll do then is just take a look at quick differences between creating parts in Onshape as you might be used to creating them in SolidWorks. Right, so you'll be familiar with SolidWorks creating a part per file. There's also multi-body parts within SolidWorks. But the difference between a multi-body part in SolidWorks and a multi-part part studio in Onshape is that a multi-body part in SolidWorks, they've all got the same material. Actually, I think you can change that, but they're not really separate parts. They are all the same, belong to the same parts. Whereas in Onshape, you can, if I extrude some of this data here, for example, you can see I'm using a sketch, and I'm using regions from a sketch, similar as you would do in SolidWorks. Then I can say, okay, well, there's my first feature, but it's also created a part. So that part has its own properties, materials, colors, metadata, everything in there. Now, if I then use this same sketch to create a second extrusion, okay, and I'll pick these bits of geometry here, and I'll reverse that and make it 0.1 inch. Now you'll see, because those are actually touching, that by default Onshape will try to add them together. Okay, but you can specify that as new. That will then generate a brand new part that is separate from that. Now, because these are separate parts, it means they can be used in different assemblies, different drawings, and you can actually then drive an entire product from a single layout, if you wish. So I could take this and drive all these parts based on this layout, and then use that across multiple different levels of sub-assemblies as well. And it's just a nice, easy way to be able to build the geometry you need just from a single part. So again, if I pick a couple of bits of geometry here, let's reverse that back and make it new. So if I were to create a pin which fits in there, for example, then you can see there is actually two parts now overlapping. And then you can do subsequent commands like doing a Boolean subtract. And you want to subtract that from that to give you the pin shape. Okay, and then you're going to get a perfect fit between the two. And you can include offsets and so on. So that's just a quick overview of what part studios are. And then when you create an assembly, again, these are slightly different. You can insert parts individually from a part studio, or you can insert everything. Now, as we saw before, these things are free to move. Okay, they can move wherever you want them to. So what you might want to do here is take one of these and fix it, and then just add some of these simple mates and say, okay, in this case, we want this thing to spin. So we'll just do a revolute mate, and as you see, as we hover the mouse over it, certain areas of the geometry highlight, center of holes, vertices, center of faces, and so on. So I want to say I want to create a revolute joint between that face there and that one there. So that's going to give me the motion that I need with one single command. Okay, and likewise then, this one over here, I could have grouped these two together first, but if not, I can simply just do, let's just do a fasten mate between that hole and that hole, and then these two are going to be fastened together. So quite often, SolidWorks users will make extensive use of the planar mate to try and get the three mating commands that you would use in SolidWorks, but in reality, most of the times, you can just do it with one. You can also then introduce offsets. You can introduce offsets in there in multiple different directions. You can have change angles of things by editing the mate connectors. So there's lots of things you can do in there to generate the assemblies, and most times you can do it much quicker than you can in any other system. Okay, at that point, I'm going to wrap up, and let me just go back to